Miss Jones collected data to determine the association or relationship between the number of hours students studied for a test and their test scores. She created the scatter plot to show her data. The line shows the general trend of the data. Part A. Write an equation for the trend line that fits the data. So the first thing I notice is that this is a straight line, and all straight lines have the form y equals mx plus b. So in order to write this equation, I need to find my slope m and the y-intercept b of where this line starts and the rate of change it moves. Okay, so I need two coordinates, and I see one good point on the line, and this is the point 1, comma 50. And I see a second point. There's a bunch of them I could pick, but I see this one. This one looks okay. It is 5, comma 90. And I want to write an equation. So the easiest thing for me is to make a table, an input-output table. Here's my x, here's my y coordinate, and I'm going to input these two coordinates into my table. So looking at 1, comma 50, I know the first number is always x, so that's 1, and on the right would be 50. For the second coordinate, 5, comma 90, again, 5 is an x coordinate, 90 is a y. And if I want to find the rate of change, I need to be able to find the changes in y as well as the changes in x. And I can do that pretty easily here. I can see from 50 to 90 is a change of positive 40. And from 1 to 5 is a change in positive 4. So to get the first component of my equation, I just make the fraction slope is the change in y over the change in x. Or in this case, it's the positive 40 for test scores over the positive 4 for number of hours studied. And I can do one last thing to that. I notice that these are both multiples of 4, so I can simplify and make that 10 over 1, or just 10. And I can fill in part of my equation already. Y equals 10x plus something. Okay. And I notice that my slope is positive and my line is moving a positive linear relationship, so that's good too. To find the y-intercept, I now take my slope and I multiply it times my x values. So 1 times 10, 5 times 10. And I just do that in my head, the product. 1 times 10 is 10, plus something equals 50. What's that something? 40. 1 times 10 is 10, plus 40 is 50. And let's see if it works down here as well. 5 times 10 is 50, and 50 plus 40 is 90. So it looks like I'm adding the same thing every time. So that is where I'm going to start. That is my y-intercept in this case. So my equation for this line is y equals 10x plus 40. And now I just need to interpret my slope and y-intercept in the next two parts. So if I am interpreting my slope, explain what the slope represents in context of the problem. Well, this context is talking about test scores and study times. So my slope is 10 over 1. And I remember the top number is my change in y. So what does y represent in this case? Y is the test scores. So score. So the 10 is the score. And the 1 is the change in x. The change in x is time studied. So I'll say study time. So I would say the slope represents every 1 hour studied every 1 hour studied, the student increases 10 points. So every time he studies 1 hour, or she, they increase their score by 10 points. And that's a prediction, since it's a scatter plot. Lastly, I know the y-intercept in this problem is 40. And I think starting value 40 would be a test score. So the y-intercept represents a student who gets a 40 because they studied for 0 hours or no time at all, so that's a bad student. But the y-intercept represents if a student didn't study, they would get most likely they would get a 40 according to this data. And then the last part is asking us to use our equation to determine the expected test score of a student who studied for 2.5 hours. So they're giving me an x value, they're giving me time studied, so like 2.5, somewhere right here. And they want me to use the equation, so I'm going to plug in 2.5 in for x, since x is time. And they're giving us a time here. So 10 times 2.5 plus 40. 10 times 2.5 is 25. And 25 plus 40 gives us 65 for y. What is y? Y is the test score. So we can say the expected test score for a student studying 2.5 hours is a 65. And we're all set.